92916. We're going to do, these are just the solutions. The key will be posted on Classroom, but the solutions are a little bit different because it talks about the rationale for doing it. So what I gave you was 9230000 micrograms. That little mu symbol, it's a Greek letter, is micro. But I want to know how many grams that is. So the very first thing I'm going to do here, I've been given an unwieldy number. I'm going to put that into scientific notation. I always convert my given into scientific notation because it makes everything else easy for these. So if, and I don't know another way to do it, I always feel like a little kid counting bumps, but 1, 2, 3, 4, 5, 6. So that's 9.23 times 10 to the 6th micrograms. Okay. So I encourage you, there are different ways to do factor labels. I would encourage you to make the boxes, to draw that sort of graphy looking thing where you have, multiple boxes on one construct. When we get into Chapter 9, which is reaction stoichiometry, you will be doing conversions where you've got like a 4 or 5 step conversion, and if you can do it all on one line, it is clean, it is easy, and it checks itself. Okay? So I'm very serious about the form because there's a really good reason to be. It's a standard. Okay, in factor label, and for a lot of you this is very repetitious and I apologize for that, we always do units to cancel. So what units I have here are going to have to cancel here. That's micrograms. That had better be micrograms. If it's not micrograms, you got a problem. Doing factor label, and this is actually in some ways not a good one to start off on, we always go through the base unit on unit conversions. So I know that above micrograms, I'm looking for a relationship to grams. And those powers of 10 give you the relationship of that prefix to the base. Now, that relationship is in a very specific order, and about half of you missed this question on the little recall quiz, which is, when you're doing these, where does the power of 10 go? Always, 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 always with the base. So I didn't used to teach it that way, and I used to let people go, oh, well, I know that 100 centimeters is 1 meter, and I put my 100 there, so I put my 10 to the second there. And I finally realized, here's the problem. You can do that for centimeters, you can do that for kilometers. All of you can do that in your head. You can do it for millimeters. You can't generally do it for megameters, you can't generally do it for picometers, you can't do it for nanometers, just because your head explodes, not literally. But it's just too large a number, and those relationships aren't intuitive. So for me, the way I prevent screwing up, and the thing that I'll tell you to do, because I've made every mistake you can make probably 10 times. Go make a new mistake, because I've got really good ways to avoid the common ones. The way to avoid the common mistake is to make a rule and to stick to it. If you're using the powers of 10, the power of 10 goes with the base, always 100% of the time. So you only use the power of 10 that is associated with the base that's in that chart. So centimeters is 10 to the negative second, millimeters is 10 to the negative third. Yeah, are there ways to do it where you would put the power of 10 with the prefixed unit and you would use a different power of 10? There are. And personally, if you start trying to keep track of them, it's a lot of brain cells you could be using for something better. Always put the power of 10 with the base unit, and you never have to think about it again. It's just an automatic. Okay, so here, this one turns out to be pretty simple because we're not going very far. I get 9.23 times, and here's what I always do. I write times 10 to the, and this is, for the entire mess, I write all of the prefixes that I'm using. And again, to avoid common mistakes, because if I try to keep track of them by myself in my little puny head, I screw it up. So that's 10 to the 6th plus a negative 6. Okay? And I literally write out plus a negative 6 minus a negative 3 plus 3, because that allows me to track better. And if you really feel screwy and, you know, lightheaded and you're having a really especially rough day, I have sometimes, when you've got like 3 or 4 exponents there, I will literally type into a calculator, and this sounds stupid, -1 plus 3 minus -6 with the signs, with the functions, and it's a nice check. And you can shut your brain off for a second and again, use those brain cells for something else. So obviously 6 plus -6 gives us 0. So this one's just 9.23 times 10 to the 0 grams. 10 to the 0, you all know what that is, right? 1. Anything to the 0 is 1. So this one's pretty cool because it's just 9.23 grams. We have not yet talked about significant figures. We're going to start that today. And that's why I was able to disregard all these zeros and they disappeared. You can't always do that, and by the end of today you'll start to understand why. Okay, so number 7, 750 nanograms is equal to how many milligrams? For some reason these are actually harder, I think, when you're staying either in units that are less than 1 base, fractionals, or transitioning between larger units. These seem to challenge, I don't know why. Anyway, more issues. So I'm going to do the thing I always do. I'm going to put my given in the first box, and that is just a standard for any factor label problem. Now, the other thing that I'm going to do is I'm going to convert that to scientific notation. 7.50 times 10 to the second nanograms is now what I have. What units do I need down here? Nanograms. Units always have to cancel, so whatever units I have here, I'm always going to have there. I'm always looking for a relationship between those units and what? The base. So I know grams are going to go there. Well, this is easy. What units do I have to have here? Grams. Whoops. Is this color scheme okay? Is that visible enough? Okay. Here I've got my grams. What units am I going into? So what units are going to be on the top final square? Milligrams. Okay. I put my units in before I do any numbers because that's your first check on whether or not this problem is going to solve itself. And you can very quickly go, okay, nanograms cancel, grams cancel, I end up in milligrams, that's what I want, solved. All right, the other thing that I tend to do for myself is before I can do something stupid, I put ones in front of the prefixed units. Because that prevents one of the common mistakes, which is trying to shove that 10 to the -2nd, 10 to the 6th, 10 to the whatever in front of a prefixed unit. If you just insert the 1 before you can do something dumb, you save yourself doing something dumb. So, nanograms, power of 10, who studied these last night? What is it? Negative, oh, they're on the board too, huh? And my mnemonic is nano 9. That helps. Okay, milli, you probably know that one from like 7th grade, right? -3rd. Okay, this is a nice one because it gives us a really good opportunity to screw up our math with exponents. Yay! So, our answer is 7.5 times 10 to the 2 plus -9 minus -3. Some of you, I know some of you do this. You look at the negative minus a negative and you do that. That's fine. If that's your mnemonic, do it. I don't. I look at negative minus a negative and I go, okay, positive. Okay, so 2 plus -9, that's -7, plus a 3, we're at to the -4th. So our final answer is 7.50 times 10 to the -4th. Our units are milligrams. Okay. Yes, ma'am. Good, thank you. In operations with exponents, anytime that you are multiplying scientific notation, so if I have 5.0 times 10 to the 2nd times 1 times 10 to the 7th. Multiplication, you add. Okay, so this would be 5 times 10 to the 2 plus 7. Okay, anytime you're multiplying two things in scientific notation together, you're adding the exponents. Anytime that you're dividing, guess what you do? Subtract, yeah. Okay, times 10 to the, what did I use? Second, divided by 1.0 times 10 to the 7th. Divide equals subtract. So this would be 5 times 10 to the 2 minus 7. So that would be 5 times 10 to the negative 5th. Okay? Does that clear up a problem for a few people? Good. Okay. Other questions, issues? Do you feel like you're ready to do these, to know what they are correctly and do them wrongly? Okay. Pick a partner. I'm going to give you 10 minutes to do 2 problems with 1 intentional mistake.